block mountain range out of this, and in the process we've uplifted this. Who knows where sea level is exactly now, but in the same process we also fault the country, so we have a series of tilt blocks and faulted pieces. So if you've ever been on a hike or looked down into the what they call the corridor of the Grand Canyon, you'll see these blocks of Bass limestone and Chenuma quartzite and so on drop down in these blocks. So what was once a flat peneplain has now been tilted and down dropped. So we've got a mountain building on our second cycle. Again, it's generating its weather, and by 550 million years ago we've eroded this off. And we're back to another plain almost at sea level, or just about at sea level. And if you'll notice now, we've got this preserved wedge over here. You've got these downdrop blocks preserved. And starting at the beginning of the Paleozoic era, about 550 million years ago, the land began to subside again, very much like is happening today at the outlet of the Mississippi River near New Orleans. And so we've generated the Paleozoic sequence right here, right up to this blue line. And what's happening over this 300 million year period, from 550 to 250 million years, is that the land has slowly been subsiding, playing tag with sea level. It isn't as though sea level goes up to the top of mountains. Sea level oscillates a little bit, but it's the land that is being shoved back and forth and raised up and down. So we start off with beach sands here in the Tapete sandstone. Then we have the Muav and the red wall limestones. This is the red wall coming through here. And then you have the red rocks of the Supai Formation and the wind-blown sand dunes here. And finally you end up with the Kaibab limestone. So you have limestones here and here, which means that you're that close to sea level. Question?
So references to what we might see on Discovery Channel, this is the period we would call Pangea, right?
Yeah, that's right. And Pangea would be where the continents had come together right about at that point right there at the top of the Kaibab. So when you're at the rim of the Grand Canyon, you're standing right there. All of these rocks of the Mesozoic era, the age of dinosaurs, have been eroded away. So after this deposition, right up about at this level, in Cretaceous time, as recently as 100 million years ago, we had a seaway up that you can see the tropic formation north of Lake Powell. And that seaway went from Gulf of Mexico to the Arctic Ocean. And so sea level would have been about here 100 million years ago. By 75 million years ago, starting then, the plates were moving around, jostling. It may have been that a plate came in off the west coast and subducted underneath the North American plate. It's like two rafts sitting one atop the other, and we're in the upper part of that raft. So the land got uplifted, so you had sea level going from about here to about here. And that was when the big uplift took place that lifted the whole of the plateau, Mingus area, everything up to this common point. Yeah, the Colorado Plateau at one time was continuous with Jerome and Prescott area. The whole uplift basically lifted the entire part of the southwest here to that elevation. And then since we now have a high standing area, we're beginning to get drainages carrying material off, and it took a long time to get rid of all of the sediment that was once on top. The green only shows a part of it. There'd be several thousand feet of sediments on this. They're being eroded off until about 8 million years ago, when the Colorado River began to start cutting its way down, and that's what I represent here as the erosion. So as the Colorado River is starting to carve its way deeper and deeper, you're eventually getting down to the point where we see the river of today. So you'd have erosion down to the level of the Kaibab limestone on each side, each rim of the canyon, plus these little residual mesas left over of the Mesozoic rocks. When you're up at Desert View, you can see Cedar Mesa right there. When you're driving up from Williams, you can see Red Butte, which is just like that. These are little tiny pockets left. Otherwise, there was once, it covered all the way to Prescott probably. Now they're retreating northward, those cliffs, to the Vermilion Cliffs and Echo Cliffs. So this is just a quick and dirty picture of what's going on in this part of the world. So when we're over in a place like Sedona, our ground level, our town level would be right about in here. So we're looking at these cliffs, just like you see in the upper third of the Grand Canyon. We can drill a hole down into the red wall. We can drill a hole all the way to the Precambrian, and we would see the same kind of rocks you see in the Grand Canyon. If you were in Kansas, you'd be looking at that. If you're in Prescott, you're looking at just this part. So it depends on where the crust is flexed and where the erosional opportunities have exposed these rocks, then you will see one thing or another. But when you're up at Desert View and looking off, you can see this flat Tapete sandstone, the flat beds of the Paleozoic, and underneath it you can see these dipping beds that are heading down, and there's the old unconformity there. So we have two major unconformities, a preserved piece down in here in this downfaulted block. So it's a very complex piece of real estate.
All done by core analysis?
Well, visual, what we're seeing in surface and what we know from the whole area here. Yep. Anyway, I'll leave that up. Well, get this. If there's any questions on it, it'll take a little bit of time to get this thing squared away here.